Hello. Oh, yeah, it works. Yeah, I'd like to express my special thanks. Yeah, I'm my great honor to give this tribute talk from Jeongseok. And this is a photo of VORTEX MODULI conference in November 2012. And it was at that time I became a Jeongseok student. It's 3 months, so it's our first trip to abroad, and here, my advisor Jeongseok is here. We have our two organizers, and I'm here. So much, yeah. Okay. So from like it's just a starting of before in my site, I just begin to learn from something from him, and my understanding of his interest from this period is about maybe studying some word crossing formula, and like I'd like to give my understanding of his interest until before he studied GLSM stuff, which probably will be given from David tomorrow. And then, first, I'd like to explain some motivational things. Motivation of studying this should be some counting problems. So in this case, counting curves inside symplectic-geometric. And in this, the first page, I want to review some work of his advisor, given time. This is about like, rational power counting. Rational means genus 0. Maybe review. In 1991, the 4 physicists Melas, Laosa, Green, Park, they predicted this many rational curves inside the symplectic-geometric. So degree 1 rational curve are this much, and degree 2 rational curves inside the symplectic-geometric. And degree 3 4 yeah, so they predicted this some like mysterious numbers, and right here where these number of degree D rational curves side. Okay, of course, it was just a prediction, and this was checked in low degrees. in math, maybe degree 2 and 1/2, because they check the degree 1 case and degree 2 case the same. But degree 3 case, I heard the first attempt was different from that one, and it's already checked by some physicists. And I heard this number was different, so they made some joint conference together. And I heard mathematicians figured out our mistake from the conference. So, and I heard this was some starting point of enumerative geometers are interested in like physics is really important. And in 96, Gibenthal is true. In some sense, he computed all these numbers at once. But here we need under some reasonable condition, assumption. And this is done by proving mirror series. And let me briefly explain how. First, there are two ways of writing Yukawa coupling. And that says this equality holds true. Okay. I'll explain what this function J later, and this H is denotes some hyperplane class inside P4, so we can consider it as a class in here by pulling back, and this X is kind of X is a Poincare pairing. So this taking values in also cohomologies in X. So we can take Poincare pairing. And that gives some function in Z and T. And this is, yeah, this is that. Okay. Here we need the assumption. So this assumption is Clemens conjecture. That's any embedded rational curves are isolated, and each component P1 component C1 P1 as normal bundle. Direct sum over 2 minus 1. This is assumption. And so I will define J precisely later, but this is a generating function of Gromf-Witten maybe or descendant Gromf-Witten. So anyway, the way of he extracted all these number is using this formula, but it's not good yet because this is not computable, unfortunately. So mirror theorem then transforms J to some easier function to very explicit function of hypergeometric series. So-called I function. And that means after some transformation J is equal to I. And this part is very computable now. So using this mirror theorem, then we transform this to I, which is explicit, so that using that equality, we can extract every number n d. And then the idea is I function, although it has some another physical meaning, but it's mysterious, but also we can describe it as some using some invariants. This is a generating function. Called Quasimap invariant, or its descendant invariant. The idea of proof is a kind of a relationship between this moduli spaces over moduli spaces which plays role over the domain of integrations to define this invariant. So so for Gromf-Witten theory, it's usually called the stable map moduli space, and in this case, quasi-map moduli, stable quasi-map moduli space. That. This relationship is called work hosting. Or maybe, yeah, also invariant level, we can say it as also work hosting formula. So this work hosting is here, this moduli space of a stable map and stable quasi-map contained in they are contained in same very large stacks in the same stack. But we can obtain this by varying stability conditions. So this word crossing is with respect to this stability condition. Defining moduli. Do you have questions so far? This can be the motivation of a word crossing or more mirrors here. Okay, then in the first talk, I would like to give the precise definition of if quasi-maps are. In this case, this is now stability condition. This governs stability, and this lies in the positive rational number. So the word is in this line of word. Okay. First of all, before giving precise definition, I want to say some remark. So we should keep in mind to construct all these things. First, our purpose, the first purpose is if epsilon is large enough, then we want to get so it actually the word stops at certain point, and so this maybe epsilon infinity makes sense. And in this chamber, so we want to get our moduli space of epsilon stable quasi-map to just a stable map. And also another thing we should keep in mind for the construction is this moduli space of stable quasi-maps the point is we are considering only smooth curve. Then this space is non-compact. Although this has a very nice absorption theory so that we can define so-called virtual class, but this is non-compact, so we cannot define invariance with this. So we need to compactify this space, and these all like every epsilon, this moduli space of epsilon stable quasi-map gives some different compactification. And one is this bistable map when epsilon is very large. Okay. So, define this precisely. Want to talk about target space first. In this case, this displays all over target space. I want to give very precise definition because sometimes it's not, maybe this information is not so useful, but particularly I thought maybe this conference it can be, I thought it can be useful. Here we start with some affine variety W. Let me use complex number field always, and having at worst LCI singularity. So it can be singular, but the singularity is not so bad. In practical situation, these conditions are not so interesting, but this affine condition is for the compactification. We have to prove actually proper in the language of algebraic geometry. Then we need that condition. And this LCI is for the deformation theory of the moduli space. But yeah, I will give you an example, so then maybe you can feel like if that is one thing is maybe if that is the space, then we can maybe we don't really have to worry about this thing. And also we consider linear C-linear Liouville group acting on W. And also let's pick homomorphism from group homomorphism. So this the C star with the multiplication. This is group homomorphism. Then this defines the line bundle, the equivariant line bundle with some. It's topologically trivial bundle on C W, but it has non-trivial action given by theta. This is bundle. Using this bundle, this line bundle, we can define GRT quotient. Which is this is our target. Also, it's not so problem even if it's not compact. But in this case, for simplicity, let's assume it is compact, smooth. Yeah, I want to give some examples. So if we take W to be just this n plus one dimensional vector space over C, and we consider standard action of theta. Take this is identity homomorphism, and oh no, this quotient is projective space. Another thing is if we let H be a homogeneous polynomial in degree 5. and let's assume having isolated Miller at the origin. Then if we take stake W to be the zero over this H inside C5, and also we consider this action like standard action induced by the action on here, and this gives and also theta is ID, and this is authentic threefold. Okay. This is our target space. And now then, this stable Quasimap is okay. So this consists of this stable Quasimap is this is P is a K pointed minus G curve with was so the so and this K pointed means this point called marking or marked point. They should be distinct, and also it's away from the nodal point if there is. Or it's same stable map case. And now this morphism F from C to our target space X is actually not. This is not a morphism into X. It's a rational morphism, but instead this is a morphism of the stack quotient. Of degree D. Now this D is actually an element of similar with the H2 homology, but in this case, to be more precise, we use G equivariant Picard group of W. So this is homomorphism of these things. So like whenever we have G equivalent line bundle on here, W, then this gives a line bundle on the stack quotient. So we get pullbacks line bundle on P, and then we can that this degree D means, and D means, so for every such L, D over L should be degree over D. So we take such the once we fix some anyway, so maybe if we take all these like integers, then this gives one degree class. And this should say pre-stability, which means the pre-image of unstable locus, unstable for the GIT stability, GIT, and this can also be non-empty subset, maybe, or maybe divide on C, and which should be, this is an effective divisor. This means just it cannot be whole of C. It's just some, the support is just finite point. And also this, usually it is called a base point in general. And distinct from marking and those. This is pre-stable condition. So far, this some conditions in data. This has nothing to do with epsilon. Now, then we have to introduce what is epsilon stability. It is this data is epsilon stable. If in addition, these two conditions are satisfied. So we use a dualizing bundle of C and twisted by this. We consider this point to be divisor. Then we twist this line bundle by this divisor, and also we have some canonical line bundle over C. This line bundle should be empty. Now we use epsilon for the emptiness of this line bundle. I will explain what this means later, and also for any geometric point X, or maybe base point. Using this is a point on C, and then multiplicity of this point X. Because this is a divisor, we can consider multiplicity, and this multiplicity should be less than or equal to 1 over epsilon. So this condition also contains some. So these are very technical. So far, maybe if for those who never seen like this definition before, then why we need such. But, like all these maybe need some like constructing some nice moduli space. But sometimes some conditions are not so necessary. Some conditions are very important. Anyway, so I try to later I will try to give you some feeling of this condition means. And then all these things can have some description with principal bundle. So first of all, having mapped to this stack quotient means by definition actually, by definition of this stack quotient, which it means there is a G bundle, G principal bundle over our source curve C, and also together with this principal bundle, this means we have a section over fiber bundle over C, whose fiber is W. Okay, so this map data is equivalent to this bundle and section data. And then we can describe this this divisor. We just using this this is nothing but this more explicitly, and also the pullback over this line bundle on and the pullback itself is on C. This is using this bundle and section data. We can describe it as so here. Yet there's no stacks on the right hand side. Okay. Then maybe in this condition, we can use this. This is not familiar. And also here, instead of this line bundle, we can use. And also multiplicity of X means it is a length of this module, length of co-corner of I. So this now I is some idea defining this closed subscheme inside okay. And so this is epsilon stable Quasimaps. Then to collect such, we have to introduce the notion of isomorphism. The morphism between these U1, F1 to C2, F2. So I just forget mark points, but let's also, yeah. This is isomorphism. An isomorphism is an isomorphism of between curves such that it satisfies needs. In this case, we say this is an isomorphism. And if there is marking, then of course, we need, obviously, we need phi should send take first marking to the second marking. And equivalently, this means in addition to phi, we need to have psi between these principal bundles on C1, such that these are principal bundles. Here we have U1, and here we have pullback over U2. And this is given by psi, and this should commit. This data is isomorphic. Then we denote by this thing, or simply, if there's no confusion, then simply I use this notation. This is a collection of table Quasimaps with some fixed topological data, GKD. Yes. Yes. Sorry, dependence. Your formula. No. So this definition contains some information. So this X needs some this morphism data. Yeah. So this F is equivalent to principal bundle. I mean P and U. Right? So whenever we have F, we need P and U. So that's why we need U to define this multiple. Yeah. Because we are considering only some, let's say this some points side C, and this point is inverse image by F. Yeah, unstable locus. So and then we can understand maybe this case is some pullback over this data over or understand locus. So when we pick a point in this set, you already somehow need U. Yeah, so like if that map is like imagine like if one point maps to unstable locus with a higher some multiplicity, then it's pullback. So anyway, so it depends on the length is depend on. I mean this length multiplicity inside this divisor. So then sorry, so maybe this should be the simplest answer. So multiplicity over X inside this divisor. So when we sorry. Yeah. So yes, at that point. Okay. Then what's the stability condition means? So suppose now this data is epsilon stable. then let's then pick a component C, like smooth component. Then the first condition should it can be, I mean, at least every such component this should satisfy tensor with the this should be empty for any such, and also we need some multiple condition, and okay, then let's consider when epsilon is infinite case. In this case, and also assume genus is 0, and also let's assume this is constant. In this case, this becomes O P1 or P prime because this is dualizing shift with -2 and number of nodes and number of markings, and this ample list over, because now this is effective divisor. So in general, this is not true, but effective divisor, this ample list is equivalent to degree of this is positive. Which is equivalent number n plus m greater or equal to 3. So it must have more than 3 or more than or equal to 3 special points, which we already know. Stability of a stable F. And also in this case, because this is almost 0, so every multiplicity of such point should be 0, which means this divisor should be empty. And also, if this genus 1 and the same conditions, then in this case, omega C prime is not isomorphic to this. So this means we need this much special point. This also already know. And let's consider this is very small number. And again, because in this case, in this computation, it has nothing to do with epsilon, right? Because the web map was constant. So in this case, we also need such condition. But in addition, when genus is 0, and even if we don't have this constant condition, we get something. So in this case, and some like very little degree, right? So let's say this is delta, and this should be positive. So because now this is, even though delta is very small, it is positive. So we need this condition. So this means in 0 plus quasi-maps, source curve C for object in this quasi-map, it doesn't contain looking like this one. Yeah. So this doesn't have a rational tail. I'll stop here. Yeah, I'm done.
Okay, so let's thank Jeongseok. Any questions?
So for 0 plus case, I mean, that moduli space doesn't contain any rational curve. That's what the implication.
Right.
For 0 plus, so Q 0 plus, so it does not contain any rational curve. Is that the implication of this?
Yeah. So here this is consisting of some C and points and map. Right? And on this C, it must not contain such.
Thanks.
Any more questions? So I think we're going to see Quasimaps in action tomorrow in the second talk by Jeongseok. And let's thank him again.